Hello, this will be the second video of the chapter Wave Optics. Okay, so today we will be talking about interference of light. So we go from the basics because basics are not given in your textbook. All that basics, whatever you studied in 11th grade with respect to interference, what is superposition and all that, we will go with the basics so that you understand it properly. Alright, so yes. So how do you define interference? I'll write the definition. We will understand it a little bit and then I will tell you the simplest way possible to feel interference. Yes. Interference is the phenomenon, okay, so it is the phenomenon of modification of light intensity. Okay, modification of light intensity due to redistribution of energy. Okay, a redistribution of energy with light energy when two or more waves meet or superimpose. Alright, that is what we call a superposition also. So what happens if there are multiple waves which are meeting? One wave, two waves. I don't care about the shape, how it should be and all. In general, we are going to understand. Let us say they are all meeting at this point whenever they want to meet. May not be simultaneously. Okay, so when they meet at this point, what will happen? Now waves, see, there is a difference in last year when we did Newton's laws, we had studied that when there are two particles colliding, okay, like two people colliding, a car and something colliding, there is the redistribution of energy in the sense the energy is redistributed in such a way that the total momentum is conserved. Remember, momentum before collision is equal to momentum after collision. That is what happens with the particles. Now we are talking about waves. Okay, now waves when they meet like this, let us say these waves are traveling like this. Okay, now they meet and then they can pass through each other. Correct? Waves can, literally get into each other and pass, and when they come out, energy gets redistributed. So there will be modification of the light intensity. Intensity, remember, it is attributed to brightness, or in other words, it is energy with light energy per unit area per unit time. That is light intensity. Correct? So there is redistribution of energy because of which the intensity gets modified. So for in simple words, the principle wherein the process wherein there are many waves which are meeting together, okay, and when they meet together, that is what we call as superimposition or superposition of waves. Alright, and they are like interfering with each other, correct? And when they interfere and finally they come out, there will be redistribution of energy, because of which there might be modification in the light intensity. Alright, now you know that light energy, if you have a point source and there is light energy which is coming from this point source, correct? Now this will be distributed uniformly in all directions because it's coming from a point source. Remember, that's how we created wavefronts and all that. Now if you have two or more such sources, let me say I have one more point source which is emitting light in all directions. Maybe there are many such light sources, correct? And when the waves superimpose, the energy distribution will be not uniform. Alright, now there will be slight modification in the light intensity, and in order to explain why it is happening, see, if you consider one source, all the light which is emitting, it is uniformly distributed. But here, when there are two light sources and light waves of these two sources, when they try to meet or when they interfere, there will be redistribution of energy. Slight modifications will be there. Alright. Now why this modification is there, that can be understood by, if you understand what is interference, what is superposition. Correct. Now if you just go back to electromagnetic waves, how was this? Light is an electromagnetic wave, and what is the meaning of it? It has electrical field which is perpendicular to magnetic field, which is perpendicular to the direction of propagation. That means the light particle, the source of light, is actually oscillating like this, correct? Because it is oscillating, there is creation of electric field, magnetic field, which kind of propagate, and that's how the energy is getting propagated. Correct? Now if you want, let us say this has having an electric field of E1 and this electric field is E2. Alright, so let us say this source electric field is E1, this source electric field is E2. In that case, if whenever they meet, I can also say the resultant wave will have an electric field which is given by the vector sum of this. So that is one way of understanding. E resultant is E1 vector plus E2 vector. Okay, now most of the times electric fields, and we do not make use of all these things. There are other properties, other parameters which we use in order to understand superposition and what happens when the waves impose on each other, when the waves meet. Alright, but one way of looking at it is, because if you get into the details, light wave is nothing but electric field, magnetic field. So if you are only looking at the electrical component, and if I know the fields of source 1, fields of source 2, or fields of wave 1 and field of wave 2, the resultant field of the resultant wave will be the vector sum of the individual electric fields. Alright, that's one way. But let us look at it in a different perspective, from the wave perspective, and I will tell you how do we go about this. Okay, so before that, we need to know the definition of two things. There are something what we call as coherent waves. We need to know what is the meaning of coherent waves and incoherent waves. It is not neatly given in your textbook, but I will explain you so that you really understand what is the meaning of this. So what is the meaning of coherent wave? Coherent here means consistency. Alright, so coherent waves means there is consistent. They are consistent waves. What is the meaning of consistency? I can predict. What is the meaning of this? See, I can predict, like when I have two waves, okay, I can predict that at all time interval, either the crust is on top of crust or the trough is on top of crust. So I can predict. Okay. Now if this wave is propagating, let us say this is time 0 and this is time 0 here. Both the waves have started. At any time after 10 seconds, I can exactly predict, like whether the crust will be on top of crust or trough will be on top of crust, or it will be somewhere in between. Okay, and I can even predict that whether crust will be on top of crust always or trough will be on top of crust always. You know this is the condition for constructive interference. Last year we have studied, but again we are going to study this year. I do not want to use these words at this stage because we have not still understood what is the meaning of all this, but since you know a little bit of constructive interference and destructive interference, I just thought I should take that example. Okay, now don't think coherent waves means it is either constructive or destructive. That is not the way, though it means the same, it is not the correct way to define coherent waves. Coherent waves means you can predict, it is consistent. At any time interval, whenever you see the crust of one wave, that the crust of other wave will be on top, will be matching with it. Okay, at any time. Let us say after 5 seconds, whenever you observe the position of crust in the first wave, the crust of the second wave will also be on top of it. Or another case could be the crust is here and the trough is here, this way. Okay, but it is predictable. So when we say the coherent waves are those waves which are consistent, that means whose behavior you can predict. Either at any time the crust will be on top of crust or the crust will be falling on trough. And what will be the condition? What does it mean? It only means that when is it possible? The two waves should have the same frequency or same wavelength. When I say same frequency, it will obviously mean same wavelength, and they should have the same phase. You know what is the meaning of phase difference? Anyway, we will understand this. You know the meaning of phase difference. So they should be in phase. Correct? Only then same frequency, same wavelength, and they should be in phase. These are the conditions for coherent phase. These are the common questions that can be asked. Let us now talk about incoherent waves. Incoherent waves means there is inconsistency. See, let us say there are two waves. Let us assume they are of the same frequency. Now, if I have to write condition, there are two categories. Same frequency and different phases. That means they have a phase difference. Or it can be different frequency or wavelength and different phases. Okay. Now what it simply means is, like, you look at that. If I have if I have like this, okay, look at that, the crust is here and this crust is here. It is not even falling on trough if you carefully see, right? The crust is here, the crust is here. Is it falling on trough? Because the trough is here, correct? Maybe when they propagate, maybe crust and trough might meet at one point, or crust might fall on crust or trough might fall on trough, but that it is not consistent. Always I cannot predict it, correct? So this could be the case. Even if they have the same frequency, let us say same frequency, okay, let me say, I'll start from, okay, this is the time, okay, so I will start this from here. Okay, so look at that, the crust is here and this crust is here. They're not exactly fitting on top of each other. So it might have the same frequency or different frequency. It doesn't matter when I cannot predict the behavior, whether crust is always on crust or trough is always on trough. At every point, if I cannot predict, that is what we call as incoherent waves. Alright, now example for coherent waves will be a laser light. And example for incoherent will be your bulb source, your torch and all that. Why? Because now that is not a point source. It is a source which is made up of many point sources, right? Now maybe the time from at which one of the points emit waves and the other emit waves, they may not have the same phase difference, correct? So that is definitely incoherent. Monochromatic light can be, because laser, it's a point source, you can consider it to be the coherent ones. There is something called as derived sources also. Now if I want, alright, how to derive a coherent source, okay, so that is called as derived sources. How do I derive it? Let us understand. Derive coherent sources. So what I need to do here is, I have waves here, correct, and then let us say I have a slit here. Now these wave fronts will pass and then both of them will be reaching at the same time, because you have to keep the source in between, and then it will create patterns which are coherent. That means the wave which is started here, at the same time will have the same frequency, same phase difference. At that moment only you are starting and they are operating with the same frequency, and that is coherent waves. You can also imagine, if you want to create coherent waves in water, alright, so imagine this is water. It's a beautiful simulation. Maybe sometime I'll send you the link, you can watch it, okay. So you are sitting on the lake and you're taking anything, it can be two metal balls or some balls which is fixed to a string, same mass and all that, and you are going to dip those two balls in the water simultaneously. You are doing this, creating the disturbance, okay, simultaneously. Now both of them will create coherent waves like this, okay. Actually we are going to talk about this in the next video, but just to understand coherent sources, this is what I mean. See, when they have the same masses and everything, and at the same time you are doing with the same frequency, it is not like, same time, but this guy is up and this guy is down. It's not like this. This will not create coherent sources, okay. Same frequency means, same phase means up and down, and it should be at the same rate, both going together up, both going together down. That is the meaning of coherent waves. I hope this is clear, okay. Now that we have understood coherent waves and incoherent waves, which is the base for interference, let us now understand path difference and phase difference concept. Now you know this, in 11th grade you have done all of this, but just to revisit, I am just going to talk about this, because unless you understand this, you will not be able to understand the next Young's double slit experiment. That's why I thought we should first clear all our doubts, okay. Let us say there are two waves, and I'll just write it as 7 lambda, I'm not counting it. This wave, by the time it reaches point P, this is the source, alright. This is 1 lambda, this is 1 lambda, this is 1 lambda, this is 2 lambda, 3 lambda. Let us say there is 7 lambda, for example, okay. And here, there is another wave which is also reaching this point, and let us say this is N9 lambda, just to keep it simple. See, do you agree this point P is closer to S1? So you have two sources, S1 and S2, alright. both of them start at the same time. That means they are in phase, right? Same time. Okay, look at that. Time 0, both of them have started. But S1 would reach P faster because it is close, whereas S2 will take a little longer to reach P. Maybe, see, exactly 7 lambda is, if I say somewhere is 7 lambda is here, so when S1 would have reached P, S2 is still here. So this difference is what we call as the path difference, the difference in the path, right? So let us say there are two ways to reach your home, alright, from one place. Let us say from the mall there are two ways to reach your home. You go in one route and your friend goes in another route. Let us say both of you are traveling with the same speed. Okay. Now what will happen if you are going in a shortcut? You will reach faster. Correct? Speeds are same. Your friend is taking the long cut, so he will take some time, and there is a difference between the path you have taken and your friend has taken. That is the path difference. The difference in the path taken by two ways to reach a point. That is the simple definition of path difference. Alright. Now, how do you understand? See, and whenever there is a path difference, always remember, whenever there is a path difference, it will lead to a phase difference. Now, these are two different terms. You should be having clarity in these two terms. Path difference is the difference in the path. One will reach faster, one will reach a little later, or if they have started simultaneously, or they would reach at the same time, but one wave has started a little later, whatever it is. Alright, so there will be a path difference, and it will always lead to a phase difference. What is phase difference? Phase difference means one wave has already reached its amplitude, the other wave is just starting, or it has reached its lower point, whatever it is. Okay, the states are not same. One wave is already reached its amplitude, maybe the other wave is in the opposite direction, it has not yet started, any time it is. That is what is the meaning of phase difference. Alright, so let us diagrammatically understand so that we really get this picture. Okay, so this is it. So I'll just draw lines like this. Please understand this thoroughly, and this is something, this is the way I had done in 11th also. Okay, so let us say this is one wave. If the second wave is also starting at the same time, reaching the peak at the same time, reaching the min at the same time, peak on the other side, and like this, it is going like this. Okay, so whenever it is this place, this wave is also at this place, whenever it is amplitude, this is also at the max position, then we say delta pi is 0. Alright, now let us consider a case wherein this is my reference wave now. Okay, now I will not start it here. The first wave has already started, and my second wave will start from this point, and it will continue. Okay, now do you see there is a path difference here? What is the path difference? Path difference is written by delta x. Okay, so path difference is given by delta x or x. Phase difference is delta pi. Okay, now path difference, what is the difference? This has already completed one wavelength, it is lagging by one wavelength. So do you agree path difference is lambda here? This is one wavelength, right? So after one wavelength, this guy is started, right? So path difference is lambda. What will be the phase difference here? Now here there is no path difference. Okay, here there is no path difference, so no phase difference. So what will be the phase difference? In terms of angle, always remember 1 lambda is 2 pi radians. Why? Because if you map it on a phasor diagram in the form of UCM, you know that by the time it reaches this path, it would have traveled one complete rotation, and that is 2 pi. Alright, now because there is a difference of lambda, can I say there is a phase difference of 2 pi radians? Correct? See, it is like this, right? So this is 90, 180, 270, 360. There is a phase difference of 360. Okay. Now let us say another wave is starting here now. Okay. So this is 1 lambda, this is 2 lambda. Do you agree delta x is 2 lambda, and what will be a delta phase? It will be 4 pi. 2 pi here, 2 pi here. Okay, now there is a way to convert it. I just want you to feel it. Okay, so I hope this part is clear. So let me write it here. Okay, so maybe only one I will write. When delta x is lambda, delta pi is 2 pi. And you see that delta x will be varying from 0, lambda, next is 2 lambda. Okay, and delta pi values also let us write. This is 2 pi. This is 4 pi. I'm just writing this because I want to conclude this. But do you agree? This is a coherent wave, right? And in a coherent wave such that the crust are on top of crust, trough are on top of crust. Here also the same thing, crust, trough, trough. Here also the same thing, crust, trough. So whenever you have this condition met, the crust will be on top of crust and trough will be on top of crust. And this is what you know as constructive interference. But we will talk about it, okay? Now consider a situation wherein, now this is also coherent, right? This is a coherent wave. Let us say the wave will start here, okay? The wave will start from here now. Now let us say it is going up like this, coming down, going down, coming up and like this, okay? Now what is the path difference? Look at that. This is lambda. It is starting exactly at half lambda. Do you see? Delta x is lambda by 2. Do you see that? This is lambda. It is starting here. So this is lambda by 2. When the first wave has reached half the wavelength, second wave has started. Okay. So what will be the phase difference now? Look at that. You can even think of like this. 90 degree, 180 degree. So isn't it pi radians now? Or lambda is 2 pi, half lambda is pi. Okay, so this is what you will see. And what you will see here is when the trough is here, the crust is here. Right? Do you see that? This is the crust, this is the trough. Okay, and similarly this is the trough, this is the crust. Okay, now let me say I am shifting it here now. Alright, so the second wave for that matter, maybe I will start from here. Okay, now another situation is like this. Okay, no, sorry, not here, it should be here. Right, so this is lambda. Yeah, it should be from here. Okay, let me start from here. Now do not do this, you have to refer this way. Okay, this is my reference way. Correct. Here also the same thing, trough and crust. Do you see that? Trough and crust. And if I continue the crust here, it will be trough here. Correct. So this is also, what will be the delta x here? Lambda plus half, 1.5 lambda or 3 lambda by 2. And what will be delta pi? This is 2 pi and pi. Isn't it 3 pi? Correct? So do you see that? And whenever you have this kind of case where the condition is that crust will always fall on trough and trough will also always fall on crust. Okay, so how can I generalize it? Let me write it here. So what will be your delta x? It will start with the pi by 2 or delta x lambda by 2 and the next one is 3 lambda by 2 and in the next one it will be 5 lambda by 2. Alright, so what will be your del pi? It will be pi. So this is pi radians. What is it? This is 2 pi plus pi. It is 3 pi. So next one will be 5 pi. Okay. So whenever this happens, crust will be on trough, trough will be on crust, and you know this to be destructive interference. I am not still defined what is destructive interference. I hope this is clear. Feel it this way. Do not get confused with the phase and path difference. Okay, so path difference means what is the difference when the two waves are starting? That is path difference. I can always find the phase difference, there is a formula, but at this stage I want you to calculate and see. Okay, so here the phase path difference is lambda by 2, phase difference will be pi, 0, 90, 180. Here this is lambda plus or lambda by 2, lambda by 2, lambda by 2, 3 lambda by 2, one way, pi, 3 pi. Okay, so this is how I want you to feel. Now, is there any way to actually link or figure out the relation between phase difference and path difference? Okay, yes, there is a formula to figure out that. Okay, and it is a simple unitary method. Okay, so 1 lambda, remember this, even if you forget things, if you remember this, you can always get back. So 1 lambda is 2 pi. If your path difference is delta x, what is your phase difference? So phase difference will be 2 pi by lambda into delta x, and that is exactly how I can calculate. If I know the path difference, it need not be always in terms of lambda by 2 and all that, or lambda. It can be even in terms of anything. Okay, it can be lambda by 4, it can be like 5 lambda, anything it can be. So if I know delta x, I can find delta pi, that is your phase difference. Alright, so this is what it is. Alright, now see, this situation is also called as in phase because the crust is on crust, trough is on trough, and this is what we call as out of phase. I have not erased this because we will finally understand this condition. We will generalize it so that you understand it properly. Alright, now let us again talk about interference. Okay, we understood that whenever you have two or more waves which superimpose on each other, right? So there it results to one wave which is called as the resultant wave. And how are they linked? The resultant displacement is given as the sum of the displacement of all the waves. Remember, what is your y in general? You write it as a sine kx plus or minus omega t plus phi if required. Correct? So this is how you write. Let me write the general form. Okay. So if I know specific waves, I just have to add their equations and I will be getting the resultant wave. I will talk about this. There is one simple example in your textbook. We will go through it, but at this stage I don't want to analyze this equation. We will just understand it as a concept first. Okay, so if I have two waves which are interfering, I will get the resultant wave, the displacement of the resultant wave or the equation of the resultant wave. I simply have to add all the waves. Okay, now that we have understood what is interference, let us now understand the types of interference. Okay, so the first one is a constructive interference, next one is the destructive interference, and third one is intermediate, neither constructive nor destructive. What is the meaning of constructive interference? Crust on crust, trough on trough. Amplitude may be different, alright? And remember, we had simulated this last year also. So if you have one wave, let me say whose amplitude is 5, and there is one more wave whose amplitude is 3. Okay, this amplitude is 3. Now they are in phase, right? Because they start at the same time. So the phase difference is 0 and the path difference is also 0. So don't you agree crust will always fall on crust and trough will always fall on trough? Only the amplitude is different. So when these two waves mix, the resultant wave will have an amplitude of A. I will talk about this formula and all that, but this is something that you have already seen. And if you have Desmos, you can just try this. Alright, so or maybe when we meet for a live class, I will demonstrate this. So whenever you have this is constructive interference. Whenever the crust and crust fall on top of each other, the resultant wave after interference will have an amplitude which is the sum of this. I will talk about it. For now, if you want, let me write it. Amplitude of the resulting wave for constructive interference is going to be A1 plus A2. Alright. Now let us talk about destructive. What is happening in destructive? Crust on trough. It's the same thing. I should have written, yes, crust on trough on crust. Something like this. Right? So what will happen? Let us say, I will just write it like this. Intermediate later I will explain. This is destructive only. So you have a wave like this, and the second wave will have its crust is falling on the trough. This is the case, correct? If it is like this, then maybe they are what will happen in this case? First, let us not analyze this way. I am just analyzing crust and trough. So if I say this amplitude is 5 and this amplitude is 2, then the resulting wave will have difference of the amplitude, whichever is greater. So I'll put a modulus. So it is 5 minus 2, which is 3. So the resultant wave will be like this, whose amplitude is going to be 3. Okay, and every coordinates, if I have to get the amplitude of the resultant, I just have to subtract their this thing. Okay, so that is what is the meaning of destructive interference. So what is destructive? Now both constructive and destructive is possible only if the sources are coherent. Now do you get it? Because when I say constructive, at every time crust always on crust, trough always on trough. Destructive, crust always on trough, trough always on crust. So there is a predictability. That means the sources should be consistent. Now if the sources are coherent, if the sources are incoherent, what will happen? Look at that. Intermediate means, let us say that there is crust here, but the trough is here. Okay, it has not even reached its maximum. It is reaching its maximum here. Do you see the crust of this is matching here, and this point is neither the trough nor the crust, right? Or this crust is matching here, right? The crust is not on trough of the first wave or the crust of the first wave. So that is what we call as intermediate, and intermediate means it is, now what will be the equation, how do I write the amplitude, I will talk about it, okay. Now these two are only for constructive and destructive. So if you have a constructive interference, the amplitude of the resultant wave will be A1 plus A2. If it's a destructive interference, amplitude will be A1 minus A2. Alright, now let us summarize all this and write the conditions, and then we will take that example which is there in your textbook. Now all this what I am saying is not there in your textbook. Okay, so that you really understand it, I am explaining all of this. Let us summarize everything for constructive interference. Okay, now what is simple words? Crust on crust, always, correct? And it is only when the sources are coherent. Trough on trough also you can see, okay, trough on trough. Okay, now what we also understood is AR will be equal to A1 plus A2, resultant amplitude. Very simple. What are the conditions? Look at that, we have already written it, right? So what are the conditions? Delta X should be equal to 0, lambda, 2 lambda and so on. Do you see a pattern there? So isn't it 0 lambda, 1 lambda, 2 lambda, 3 lambda? So isn't it in general, no, next will be 4 lambda, right? I did not write this. So it will not be, hold on 1 minute. Yeah, it will be, this will be 3 lambda, sorry, lambda it is. Yes. Maybe I'll write the phase difference first, it becomes easy for you to visualize. So what will be the phase difference? 0, 2 pi, 4 pi, correct? 0, 2 pi, 4 pi and so on. So phase difference in general is, can I say even multiples of pi? Even pi. This is the simplest way, okay? It's given a little confusing in your textbook, but I will also write that so that you do not have to get confused. Whatever is given in your textbook, I will write it here later. First let us understand that. Okay, now delta X, what will be the path difference? It is lambda, right? So it is either 0, lambda, 2 lambda and so on. So path difference will be n lambda. Okay, so this is what it is for constructive interference. Okay. Let us write the condition for destructive interference. Destructive means this is like this, crust on top of trough. So this is also when the sources are coherent, and the resultant amplitude will be A1 minus A2 under mod. I hope this part is clear. So what will be the phase difference now? We have already written it, right? Phase difference is going to be, that's the reason I have written it here, so that again I don't have to go back. Okay, so isn't it odd pi? 1, 3, 5 and so on. And what will be the path difference? Path difference is lambda by 2, 3 lambda by 2, 5 lambda by 2 and so on. So it is odd lambda by 2. This picture I want you to understand. Alright, now I don't need this because this is what I need. Okay. So for a constructive interference, the phase difference should be 0, 2 pi, 4 pi or even multiples of pi. And destructive interference, the phase difference should be odd multiples of pi. Very easy. Even, odd multiples. Okay. Path difference, now it is very easy if you know this. 2 pi means lambda, 4 pi means 2 lambda. Or use this formula also. This is also fine. Delta pi will be 2 pi by lambda into delta x. So delta x will be rearrange this. That's also fine. But every time to calculate, you remember the general one, it will be easier. Okay, so it is nothing but n lambda. For destructive interference, because we understood it as the second wave will start when it is reaching its 0th position. That means the phase difference starting is pi, correct? And pi is nothing but lambda by 2 because 2 pi is lambda. Okay, you have to remember this also. 1 lambda is 2 pi. Everything else will be fine, correct? So now you will not have 2 lambda by 2 here. Why? Because 2 lambda by 2 is nothing but lambda, and lambda is constructive. So it is odd lambda by 2. Alright, so I hope this part is clear. Alright, now if you recollect, alright, let us say there are 2 waves. This amplitude is A1, and let us say there is one more wave whose amplitude. Now it may be coherent, it may be, when the condition may be such that crust and crust may not be on top of each other. It is like in intermediate interference. Okay, so let us consider the general case. Now, how will I write this in vector diagram? Let us say there is a phase difference of del pi between them. There is some phase difference. Let's not bother about it. Okay, now if the phase difference is any of these two, then if it is this constructive, it is this destructive. But if they do not have, let me say it is in general something. It may be constructive, destructive, or an intermediate. How do I write it in the vector form? So this is A1. The length of this is equal to the length, the amplitude part. That's how you write vectors. Correct? And let us say this is A2. Okay, whose now A2 should be smaller according to my diagram, lengthwise. So let me say this is A2. And what should be the angle between them? This is your del pi. This is how I can write it in the vector form. So the resultant in the vector form will be somewhere here. And what will be the magnitude of the resultant in general? See, this is only for constructive and destructive. In general, in the intermediate case, what it will be? You know it already in the vector form. A square plus 2a1 a2 cos del pi. Done. Okay? So I know the magnitude. What is a1 here? Amplitude of the first wave. A2 is the amplitude of the second wave. And I am done. Del phi is the phase difference. So I can find the result. Now, even if you look at it, what will be cos delta pi for constructive interference? You will get back this. Okay, for constructive interference, you know delta pi is 0, 2 pi and all that. Let us consider the case of 0. So this becomes cos 0 because which is 1, and when this becomes 1, this is gone. So it is this square plus 2 a1 a2. Isn't it a1 plus a2 whole square? Root and whole square gets cancelled. Exactly, you are getting this. And for destructive interference, you know del phi, let us take the starting value, it is pi. So what is cos pi? Cos pi is cos 1, it is minus 1, correct? So this will become negative here. So a1 square plus a2 square minus 2 1 a2, which is a1 minus a2 whole square under root. We are back getting this back. So this is a general formula. I can very easily get the conditions for constructive and destructive. Now you should remember this. Whenever they give you constructive and destructive, as a shortcut you can remember this. Alright. Now let us say if this wave is having an intensity I1 and this wave is having an intensity I2, what will be the intensity of the resultant wave? Smaller capital. Okay. It is given as I1 plus I2 plus 2 root I1 I2 into cos delta pi. Alright. Now if you want, I will give you a shortcut for this, but if not, you can just remember like this. And also remember, intensity of any wave is proportional to its amplitude square. Okay. Now this too is what you need to know. This is for any kind of interference. Special cases we have discussed. Okay. The resultant intensity will be I1 plus I2 plus 2. Don't get confused. There is no overall root here. There is only root here. Please write the formula properly. Now, if you want to consider this here also, this part will be 1. And you can write this as I1 plus, you can write this as, if you want, I will write the shortcut here. IR for constructive will be root I1 plus root I2 whole square. Because you know, you can write it as root I1 whole square plus root I2 whole square and so on. And here it will be IR, it will be equal to root of I1 minus root of I2 whole square. When you are squaring it anyways, it doesn't matter which is greater. I hope this much is very clear. These are the basics. Now let us go back to your textbook and try to write this in that form whichever is given in your textbook. Alright. This is just the understanding. This is my way of remembering the formula. Even pi, odd pi, n lambda, odd lambda by 2. Very simple formula. Okay, but it's slightly given in this way. Now let us even try to do that. So what are they doing is, I will write this because I need to update this. Okay, so I will only be using this space. So if you have two sources of light, S1 and S2, and let us say this distance and this distance is exactly same, then do you agree they will have no path difference? So they will meet constructively only, no path difference, right? Because they are reaching at the same time, distance is same, correct? But let us consider an arbitrary case where you have S1 here, and let us say this is your point P and this is S2. Now look at that, this is the midpoint, okay, and this is S2. Now do you agree, there, this is your screen, okay, this is your screen. Now basically you have two sources, alright, and this has to be your coherent source. I have two coherent sources, alright. That means, what is the meaning of coherent source? It is consistent, they should have the same frequency or same wavelength, and they should be in phase, correct? Now, the light waves will reach P, the light waves from here will reach P also. Now, because this is farther, there will be a phase difference, correct, and also a path difference. Now, let us write this first wave, the equation as A cos omega t. You can write it as sine also, nothing, no problem. But in general, we are writing it. I am just following your textbook. And the second wave as A cos omega t plus phi. Right? Because there is a phase difference. Right? So this is omega t plus phi. Okay? So this is the equation for wave 1. This is the equation for wave. So what will be the resultant? You have already, and let us say the intensity of this is I naught. Since the amplitudes are same, their intensity is also same. Now amplitude need not be same in general. Like I said, 8, 3, it can be anything. But in this equation we are taking it as same amplitude. What is the difference? Amplitude is same. They have a phase difference. That's all. They have a phase difference of phi. Alright. Now if you ask me at this point P, what kind of interference is there? To understand that only we are writing all of this. Okay, to understand that we are going to understand it this way. At this point P, because there is a path difference of S2 minus S1P, there will be a phase difference also, because they are reaching at two different times. Because the path is longer, therefore there will be a path difference, and whenever there is a path difference, there is a phase difference. That's the reason I'm adding. Okay, and we are considering this to be of same intensity, I naught, I naught. So what is the resultant wave? YR is equal to Y1 plus Y2. So let us write it this way. Okay, ultimately the final result is the same thing, but we will understand it in the form of this equation. Cos omega t plus phi. So it will be A cos this plus cos this, isn't it? Cos C plus cos D, 2 cos C plus D by 2. Okay, C plus D by 2 will be omega t plus omega t, 2 omega t plus phi by 2. Correct? So I can write it as omega t plus phi by 2, or let me write it the way you understand. Okay, 2 cos C plus D by 2. So 2 omega t plus phi by 2, and cos of C minus D by 2. C minus means it will be minus cos phi by 2. This and this goes. Correct? So this is what you have. Okay, now I don't want to erase this. Okay, let me write this summary here. It is A into, I don't need to have the bracket. So can I write it as 2A cos, this I will write it first, cos of negative angle is positive, and this will be cos omega t plus pi by 2, correct? Now this is a constant, right? Do you realize that this is the amplitude of the resultant wave, right? Whatever comes in the cos, this will be the amplitude, and this will be the inner function. So this will be the amplitude now. So if this is the amplitude, what will be the intensity? You know, intensity of the resultant wave is proportional to the amplitude square, correct? And what is my amplitude here? So it will be equal to, if I square this, 4a square cos square pi by 2. This is what I get, right? So now I told you in the previous one that whenever I wrote this equation, this was having amplitude A, this was also having amplitude A, and this intensity is I naught, this intensity is I naught. So intensity is proportional to the amplitude square. So instead of A square, can I write it as I naught? So that is how I get 4 I naught cos square pi by 2. This is the intensity of the resultant wave. When these two waves interfere, this will be the intensity of the resultant wave. Okay. Now let us say what should be the condition for constructive and destructive interference. Okay. Now if you are thinking at a point P, whether it is going to be constructive or destructive, you will understand that when we do the Young's double slit. Okay, here we are not going to do all this in this video. We are only going to understand, if I have two coherent sources and there is some arbitrary point P, what should be the condition for constructive and destructive interference. First, let us talk about constructive interference. Now, constructive interference, you know that
amplitude becomes maximum, right? It is the sum of that. And when amplitude is greater, don't you agree intensity will also be the brightest? So constructive interference will always give me the brightest light. So in the screen, you will see bright patches, okay, bright points, and that is what we call as interference maxima. So here you will see some bright patches. So this is bright, this is also bright, this is also bright, okay, some bright spots we see. That means if I just have to decode it from the screen, wherever you are seeing bright points, that is the condition for that is where constructive interference is happening. But condition wise, let us see. Now if I told you for constructive interference, intensity will be maximum because amplitude is maximum. And if this has to be maximum, what should be the max value of cos square pi by 2? So cos square pi by 2 should be 1. You know the maximum value. That means cos pi by 2 is also 1. That means pi by 2 is going to be 0 or 2 pi, like that, right? Do you agree with this? So what is the meaning of this? Pi is equal to either 0, or if it is next, it will be pi, yes, cos pi by 2 is 1, or pi by 2 is 0, 180 no, 90 no, 180 yes. Okay, it will be pi also. Cos 180 is also 0, right? So this way it is going to be, right? So do you understand that you will be getting the same condition if you cross multiply? If you are talking, this is pi by 2, right? So what will be pi? 2 pi, 4 pi and so on, correct? So you are getting the same conditions now. Do you see whatever I have written? For constructive interference, this we have understood by actually analyzing waves. This is by the formula, okay? So isn't it nothing but even pi? So in your textbook they have given it as plus or minus 2n pi, where n is 1, 2, 3 and so on. That is also fine, because when you put n, any value, n is 1, 2, 3, you will always get even. N is 1 means 2 pi. 0, yeah, 0, 1, 2, sorry, n is starting from 0. When n is 0, it is 0. When n it is 1, it is 2 pi. N is 2, it is 2 pi. It's the same thing. Okay, remember it as even pi or plus 2n pi, it is left to you. Alright, and the path difference, how they have calculated is, path difference is nothing but lambda by 2 pi into phase difference, correct? I always used to write phase difference as 2 pi by lambda, this is like this. So you will write it as lambda by 2 pi, put the value of phase difference. When it is 0, what will happen? When it is 2 pi, what is happen? When it is 0, you will get it as 0. Second time when it is 2 pi, you get it as lambda and so on. Are you getting this? So finally, you will be getting path difference as 0, lambda, 2 lambda and so on. And that's exactly what I have in lambda, where n is equal to 0, 1, 2, 3. Alright, so now let us try to understand the condition for destructive interference. That is when IR is minimum. Okay, that means you will see a dark patch, dark region. So you will see some dark region like this. So this is destructive. Okay, so somewhere you will see dark region, destructive, bright region, constructive. Okay, so now that is also called as destructive minimum because it is minimum. So when is it minimum? Cos square pi by 2 minimum value will be 0, right? And if it is 0, what will be the value of pi? Okay, let me say, that means if I take the square root, cos pi by 2 is also 0. So what is pi? Cos 0 starts from 90 degrees, correct? So isn't pi going to be pi by 2? Let me write. Okay, so pi by 2 will be 90 degrees, 270 degrees and so on, or it is what is that, pi by 2, 3 pi by 2 and so on. This is pi by 2. So what will be a phi? You will just cross multiply. So it is pi into 2 means 3 pi and so on. And isn't that what I have got? Right? So but they have given the general formula as 2n minus 1 into pi. Okay, so where do I write it? Maybe I'll remove this. There, this part they have given as 2n minus 1 into pi. It's the same thing. See, you remember it as odd pi. N is 0. That means it is just pi. N is 1. 2 into 1 is 2. 2 minus 1 is 1. So, it is again the same thing. Alright. So, this is what you are getting. Right. So, what will be the path difference? path difference is odd lambda by 2 or odd numbers, see, forget about that. You know 2n is nothing but even. I think this is the easiest way. This is even number. 2n minus 1 is your odd number. Plus 1 is also odd, but you will not get the previous value. Getting it? So that's the reason you will write it this way. Okay, so this is odd lambda by 2. So you can write it as 2n minus 1 lambda by 2. Done. Okay, so either I prefer to remember it like this. If in your textbook, in your notes, I think it is given like this. If you want remember like this, it doesn't matter. This is same. Okay, so just remember even is 2n, odd is 2n minus 1. So even pi, odd pi, n lambda, odd lambda by 2. Very, very simple. Alright, so this is what we call as interference minimum. Alright, now if neither of these conditions are there, if the phase difference continuously varies with the time, there is something called as average intensity, because sometimes you know what will be the average of this. So you know average intensity means you will write it in angular brackets. It will be 4 I naught into cos square pi by 2. It's average, correct? And what is the average value of this? Isn't it half? Average value of cos square pi by 2 is half. So you will get this as into half, or it is I naught by 2. Okay, that means I will be 2 times, sorry, not I naught by 2, 2 I naught. Okay, 2 I naught. So I know I will be 2 times I naught. Okay, so this is the average intensity. Okay, or you can even consider it like this, construction plus destruction by 2. That way is also fine. Alright, minimum, maximum by 0. Maximum is 4 I naught. See, you can also see like this. Average is construction plus destruction by 2. Constructive interference is 4 I naught plus 0 by 2. Right, so isn't it 2 I naught? It's the same thing. Alright, so you are getting it as 2 I naught. So that means whenever, and this is the condition for incoherent, right? So whenever you have incoherent addition of waves, this is the case of incoherent addition of waves where the intensities are just adding up. Whatever you have that intensity, just add up. That's all. Alright. Now just to be on the safe side, remember that formula. Irrespective of constructive, destructive, intermediate, remember that formula. Okay, IR is equal to I1 plus I2, 2 root I1 I2 into cos pi. That will be the safest of all. Getting it? Yes. Alright, now what should be the condition for the sustained interference pattern? Sustained interference pattern means the sources must be coherent first of all. If you want a consistent pattern like constructive, destructive and all that. So it should be coherent. That means the sources should have the same frequency, same wavelength and constant phase difference. Alright. Now the sources also should be closer to each other so that you get a correct pattern on the screen. Alright. For that the sources should be quite close to each other, and they should the distance from the screen should be larger. You will get a distinct pattern. It is more more clear and all that. More of this we will study in the next video. Alright, so now this is very, very important. This part, I hope this is clear. This picture should be there in your mind. Even pi, odd pi, n lambda, odd lambda by 2. You remember it in either ways, it's fine with me. Alright, so quickly let's take one numerical. Now two coherent sources, there are two coherent sources of intensities I0 and 16 I0. It gives rise to an interference. It results in the interference. Okay. Calculate the intensities on the screen. Okay, so you have to calculate the intensity on the screen. What is the meaning of intensity on screen? It is the resultant interference. Okay, resultant interference intensity corresponding when path difference are first one 0, second one lambda by 4 and third one is lambda by 2. So what it tells, there are two coherent sources, okay, I0 and 16 I0, and there is a screen. I don't care whatever it is, okay, wherever is the point. What are they saying? You have to, let us say at this point
the path difference is 0. Somewhere here the path difference is lambda by 4. Somewhere here it is lambda by 4. Okay, path difference is 0 means the distances are same, right? Here the difference is lambda by 4, that means the distances are not same. You just have to calculate the intensity corresponding to that. Alright, now let us do this. Case 1, first case, when what is the meaning of that path difference? Corresponding, okay, let us write the corresponding phase. Okay, let me write it this way. So first case is when delta x is 0, path difference is 0, and when the path difference is 0, you know phase difference is also 0. Correct? So you want to calculate the resultant intensity I1 plus I2. Now you know that I can write it as I1 plus I2 root a whole square, also the shortcut, but I will just write it like this. Okay, so I1 is I0, this is 16 I0, okay, plus 2 into I0 into 16 I0 into 0. Cos 0 is what? 1. So this part will go. So what will you get? I0 plus 16 I0 plus, this is 16 I0 square, I0 will come out, 4 will come out, 4 into 2 is 8, so this is I0, what will this be? 16 plus 8, 24 plus 1 is 25, so this is 25 I0. And do you agree this is the case for constructive interference? Correct? And the intensity should be maximum here, 25 times I0. It is greater than both. Correct? Don't just add up the intensities. Only amplitudes you can add up. Alright? Intensities, the short form is, for constructive interference, it is root I1 plus root I2 whole square. Either you use this or use this. Okay? So that's, anyway you're getting the same thing. Look at that. Root, this is 4. And this is 1. 4 plus 1 is 5. 5 square is 25. Alright, maximum it is. That means in all the other two cases, I cannot get this much. A value should be lower than that. Okay, now in the second case, delta x is lambda by 4. What will be the corresponding difference? Now, if you want, you can calculate it. Phase difference is 2 pi by lambda into path difference. Yes. So, it is 2 pi by lambda by 4 in, by lambda into delta x, okay, into lambda by 4. Lambda gone, so this is pi by 2. This is one way of understanding. Or in other words, look at that, one way, this is lambda, this is 2 pi. Lambda by 4 is nothing, this is lambda by 4. Isn't this nothing but pi by 2? This way also you can understand. One wavelength is 2 lambda, half wavelength is lambda by 2. This is 1/4 wavelength, it is pi by 2. Alright, so I think this is fine. This way also you can do. So let us now find the intensity of the resultant wave. It is I1. What is your I1? I0 plus 16 I0 plus 2 into I0 16 I0 into cos pi. What is cos pi by 2? It is 90. So this is gone. So it is 17 I0. Okay, so this is gone, 17 I0. It should be lesser than that. Okay. Now let us calculate when it is lambda by 2. What will be the path difference? Okay, 2 pi by lambda into lambda by 2. It is pi. Remember, when it is pi, this is the case for destructive interference. Minimum. Whatever answer you get, you should be lesser than this. Okay, that is what you need to calculate. Okay, just a quick verify. And to visualize this, delta x is lambda by 2. It has to be pi. Correct? We know this only. So what is IR? I0 plus 16 I0 plus 2 into I0 16 I0 into cos 180. Cos 180 is minus 1. Cos pi. Right? So what you get here is I0 plus 16 I0 minus, this minus will come here, minus it will be 8 this. Right? 16 minus 8 is 8. 8 plus 1 is 9. So this is the intensity. Alright, so this is the dark fringe. You should get the color as dark because this is destructive, and this will be the bright fringe, first bright fringe, the central maximum it is, because it's 0. Correct? And this is somewhere in between. Okay, now this part, if you don't understand where is the position, in the next video when we do Young's experiment, you will get to know. Alright, yes. Alright, so that's about it in this video. We will talk about more of this. In the next video, we will be doing Young's double slit experiment.